Okay, so this video is going to be about the LAN-Caster engineTest demo game that's in there. But really what it's about is about kind of the built-in, the mechanics of LAN-Caster, because the engineTest game is something that was created to test each of those mechanics in isolation. So by looking at the engineTest, you can actually see how each mechanic individually works. So there is actually a launcher script for this, and if I just, I'll walk you through all the details here before we do this. So there is a run engineTest.bat in the root of the LAN-Caster folder, and it does two things. It runs the game engineTest. It runs it at 60 frames per second. We specifically try to run it a little faster than the default just to try to show if there's any problems with the engine. We run it in test mode, and we want to run it with verbose logging turned on. Now this game only takes one client, and that's something it doesn't bother testing the multiple clients. It's really more about testing the mechanics. So I'm going to go ahead and run this. So I will double click, and we get our basic window up. Our player here is named Bob. There's a little bit of explanation text for each one. And just before we start, maybe I will show there are a great number of tests. If we go into the source directory, into the engineTest game, and into maps, you'll actually see there are currently about 25. I'm only going to cover the first few of these. And all the ones I'm going to cover in this video are not going to have any added code. In other words, they are going to work purely from the tile set and map data. There's no subclassing of server client, server map client map, or anything else. I think that's almost entirely true. There might be one or two small exceptions, and I'll point those out when we hit them. So let's start with where we started here. So on startup, the first thing we see is that our little player here named Bob, he's a very simple tile object. He started up and we were able to move him around. So let's look at how that worked, because this is testing the idea of a object in tiled on a map that can be linked to a player. So I'm going to go ahead and open tiled. I will close whatever is in there right now, and I will open up. So I'm in engineTest. So I'm in LAN-Caster source, engineTest maps. I'm just going to go to the very first map here, this test01 start, and open map.json. So we'll see on this map, there's only one thing of actual interest here, and that is the fact we have a sprites layer. So that's an object layer. The static text layer actually has nothing to do with this particular test. It's just giving some information there, so it doesn't actually impact anything. So we have an object layer called sprites. On that object layer, we have a tile object that we have named Bob, but that doesn't impact it. What does impact it, it has type equals player. So every time you have an object on the sprites layer that is of type player, it means that can have a client linked to it. So when the server starts, it searches for all of the objects on the sprite layer that are of type player, and it allows clients to join and links them to those objects. So now when I go to the game, this client will control that sprite object. So that's all there is to it. So if you want a 4-player game, you create 4 of these. So I can just create a couple more Bobs, and I could then have 2 more players join if I were to restart the game. So that's our first very simple game mechanic, is how do the players actually get linked to their objects on the sprite layer. All right, so that's the first one. Very simple, very straightforward. So the next one, and what I'm going to do, if you haven't looked at this, we are running in test mode, and you can read at the top of the screen. F3 will jump forward a map, and F2 will jump back. Because this is to be absolutely minimal, there are no map doors here in the demo, so we have to press F3, which is what I just did, and we just jumped forward. Also, if you haven't played in test mode yet, the right mouse button will just jump the player sprite to any location, which makes it very easy to test. So I'm going to jump the player sprite inside the test area here. So the next thing here is the move linear mechanic. Now you can look in the in a few different places, understand how this is all working. And I'll just give a quick tour of that. But what I really want to talk about is the move linear mechanic itself. So very quickly, what's happening is when I click the mouse, we can go into the code here. We can go source, engine, into the engine itself, and we can go into the client.py code. So this is the client object or the client class. And at the very bottom of that class, you will see the process events. And this is called from the main loop of the client. And when a event comes in, we call process event for the single event. And when the user clicks the mouse, what will happen is we will get a XY location of where the user clicked the mouse, and we will send a message to the server. So we send a message. There is a couple types here because if we're in test mode, but we normally send a player move message. That's the normal message type we send with that destination X, destination Y. So that is what happens. On the other side of that, the server will have a function to handle message type player move. So if we go check the server, so I'm in the engine again, server pi, and I'm just going to search for player move and find that function. So this is the method that handles that handles messages of type player move, and all that it does, it finds based on the IP that the message came from, it finds the player that matches that, and it finds the map the player is on. And then on that map, it uses part of the move linear mechanic. So it says set move linear. And for that particular sprite, it sets the destination X, destination Y from the message. And also the move speed, which is the default that's in the player. I won't get into the details of that, but I will go talk to and you can go look at these different things and what's there. But the main point here is it actually uses the mechanic. So we've seen the user click the mouse, the client send the message to the server receive the message, and then find the map the player's on, and then use the set move linear. So now let's actually go look at the mechanic. So mechanics are set up inside server map. So if I go to the engine server map, I happen to know where this mechanic is. And the move linear is actually the first mechanic. So I'm going to scroll down. And maybe I'll start with the function that sets it. So there's two functions. There's a set move linear and a delete move linear. The set move linear, we just saw the call for it. And all it actually does is, for the sprite, it adds a move key to the sprite object. And in that, it says that our move type is linear, that we have a destination X, a destination Y, and a move speed. So we just store that. And then slide equals true. I'll talk about that in a minute, but typically speaking, and actually I'll show it to you, if you want a player to slide, so, if I move here, you'll see that I'll walk towards my destination and then I'll slide a little bit along the wall to get closer. That slide being turned on is what you're seeing there. If you don't have slide, if I hit a wall and can't move directly towards where I'm trying to go, so if I click there, then I slide, I would stop sliding. I wouldn't slide at all. I would just stop at the wall. But again, that's a detail. So this sets the movement for the sprite. It doesn't do anything. It doesn't actually move the sprite. It just sets the data up. And then when the server takes a step forward, and the server's going to take a step forward 60 times a second in this case, what's going to happen is that the stepping mechanism of the server is going to realize that that move attribute that we added is inside the sprite, and that move type is linear. So it's actually going to call step move linear. Again, it's going to do that because we said that the move, when we set move in the sprite, we set its type to linear, which means that every step we're going to call the method step move linear. So that's exactly how that works. So step move linear simply takes in the sprite, and this is called every single step. There's a video on server stepping. You can go learn about how these functions are called and in what order they're called. But effectively what this does is it checks to make sure that there is in fact a move key in the sprite and that the move type is a linear. And in that case, it gets the data it needs from that. And it converts the speed. So speed in LAN-Caster is always stated in pixels per second. So this is actually one case where we're actually using that global variable of the server. So we want to go find out what the frames per second is of the server. And this is simply how we access it. The server is a global variable and we access it as engine server server. So now we have the server object that's running and we can get its frames per second. So we take our current speed and we divide it by frames per second. That gives us our step speed, or how far to move per step. Again, a step and a frame is kind of the same thing in the LAN-Caster terminology. So we do some magic here. I'm not going to go into all the details here, but we find out what speed we want to go, and then we compute an angle that we're trying to go towards our destination. And then we do what's called some bounds checking. So what we're going to try to do is we're going to try to first of all say, are we very close to our destination? In other words, could we get there in this one step? And if so, we simply set our new anchor point to that destination. This is a key point to remember is, and this is talked about in other videos, we really are moving the anchor point of the sprite. So a sprite will have its top left corner, XY location, will have a width and a height, so you can figure all the corners of the rectangle for the sprite, but really there's also an anchor point. Now by default, it's the center of the sprite vertically and horizontally. But when someone creates a tile set, they can also set that anchor point to be usually the feet of a character, so that when we're moving them, we're moving where their feet land. And if I go back to the demo here again, if I click very carefully where the tip of my pointer is, you'll see that Bob's feet go there. Now that's because Bob has his anchor point set in his tile set. So that's why that's happening. So again, we're setting a new anchor point where that's what the destination is. Okay, so if we are too far from our destination to make it there this one step, we actually use the geometry function project, and that moves us towards, it projects a line from where we currently are located, our current anchor, in the direction that we want to go at the amount we want to move. Okay. So we do all these things. We figure out where we want to try to move this step. And again, this is only done for this one step. We're not, we're not worrying about what's happening 1/60th of a second from now. This is just for right now. So we figured out where we want to move to. Now we have to figure out whether that's a valid location. And this is something that is very important when we talk about collision detection. So we're going to use function from the map. This is from the base map called check location. So if we go to the base class for the map and we actually find check location, I actually have a faster way to do that. Oh, I shouldn't have done that. I should double click this. Sorry, let me make sure these files stay open. Okay, let me scroll down again. There we go, check location, and I should be able to go to definition. There we go, much simpler. Definition in map. Okay, so here's the check location function. So you can read this function for what it does. There's some good documentation here, but effectively it takes in an object, a new proposed anchor X and anchor Y, and it tells you whether or not that's a valid location. So if we open this map, so let me close this map, discard my changes there, and I'm going to go back to maps, open up map 2. So if I look at this map, I'm going to turn some things off. I'm going to turn off the graphics on the bottom, and I'm going to turn off the static text. So on this map, to start with, you notice there's no sprite layer. We don't need a sprite layer when we define the map, because the LAN-Caster server will add the sprite layer for us, and there's nothing on the sprite layer to start with. There's only going to be the player when they arrive at this map. Will the sprite layer have something on it? So, but the LAN-Caster server will create an empty sprite layer for us, so we don't need it here. We do have, though, an inbounds and an out of bounds layers. And I'm just going to look at these in turn. So that is what is on out of bounds. And those are, oh, sorry, I had that backwards. Those are the rectangles on out of bounds. And those are the rectangles on inbounds. So the way the logic works, if we turn those both back on, maybe I'll turn the static text on. You can read several things here about how this all works. The full explanation of how bounds checking works is actually with the check location object. So again, I'm in engine map.py, and this will tell you whether or not an object overlaps and if it collides with an inbounds or out of bounds layer, how it works. But the short version is simply this. And it's actually very easy to see if we actually just play the game. So all of the brick are covered by rectangles on the out of bounds layer. All of the checkerboard is covered by rectangles that are on the inbounds layer. And this kind of grid pattern or whatever you would call it here in the middle, that is covered by both rectangles in the inbounds and the out of bounds. So what this means is that Bob can walk around the checkerboard, but can't walk on the brick, cannot walk on the grid, and actually can't walk in the open space either. So if I jump in the open space where there is no rectangles on inbounds or out of bounds, Bob can't walk around. So what this means is if Bob is on a inbounds, Bob can move. But if there's an out of bounds overlapping it, Bob can't. So the precedence is if Bob is on out of bounds, Bob cannot move. If Bob is on inbounds alone, Bob can move. And then if you have a map that has no layers for inbounds or out of bounds, and I'll go back to the start map, because the start map didn't have these layers, Bob can move freely. The other option is if you don't have inbounds, you only have out of bounds, then Bob could move around freely as well, and anything that's not out of bounds. So you can omit the inbounds completely if you just want to create areas where the players can't go, or any sprites for that matter can't go, because again, many things will use that check location function. So that's the basics of how movement works. So if we go back to our server map, we've done our check location. We know whether we're inbounds or not. Now, if we're not inbounds, we can try to slide. And what's effectively happening there is as Bob walks towards a wall, if he can't walk into the wall, he might be able to move a little bit along. Then that's just a little adjustment there. So I won't go through the details of all that code, but that's what this is saying is if we can't and we're supposed to slide, try to slide. And in this case, it just tries to move the sprite left, right, up, down. It's a fairly simple algorithm. You can read that for yourself. All right. So if either moving directly or by sliding, we end up finding that we are in bounds, then what we do is we ultimately want to set the object's location by anchor. So this actually changes the object's location. You can go look at that function in the map.py is where that function or method lives. But the other thing we do is if we've reached our destination, we actually call the del move linear. So that's down here as well. So this is how you stop something from moving. So if the movement's in the sprite and the movement is type linear, which it is for us, for everything, we actually delete that. And we also set the map has changed. Setting map change is important anytime we do a change, because it will actually ensure that the map gets sent back to the players on that map, because they'll know there's an update. When you make a lot of function calls at the lower level, like set object location by anchor, it will actually call set map change for you, so you don't have to do it. But if you're not sure, it's not a bad idea to call set map changed. Okay, now if we're not in bounds and we can't move, we actually just need to stop. So we call delete the move linear there. So if we reached our destination or if we can't move, we're going to stop. And if we are in bounds and we have a new location, we're actually going to move there. And that's the move linear mechanic. So again, we have the ability to set a destination, remove a destination for any sprite. Doesn't have to be a player, anything on the sprite layer. And then every step Every time the server takes a step forward, so 60 times a second in our case, step move linear will be called. Okay, and that's the move mechanic, or the move linear mechanic. At the end of the engine test, there's a couple other examples of custom move mechanics, but this is the basic move mechanic that exists in the LAN-Caster game engine. All right, let's move on. So I'm going to press F3 again, which is going to move me forward to the next map. All right, so this is a map. Now again, you see there's no inbounds or out-of-bound layers, so I can move around freely. This is a demonstration of the MapDoor mechanic. So a MapDoor can do two different things. It can transport you between maps, and again, it can transport, I believe, any sprite between maps, or it can transport a sprite within the same map. So for example, this door takes me over here, and this door here takes me to the next map, and this door will take me back to the map I was just on. So let's look at how this is set up. Again, there's no added code to the engine. This is all built in, just like the move linear was. So let me close the move linear map, open up the MapDoor map. So the way you make a MapDoor, and to start with, I'm going to turn the graphics off. The graphics have nothing to do with this. I'm going to turn the static text off so you don't have to see that. Actually has nothing to do with it. So what you're seeing here is two layers that we haven't seen before. The first one is called triggers, and the second one is called reference. So let's start with triggers. So I'm going to turn reference off. So what we see on triggers is two rectangles. And if I go look over here, effectively the doors I leave from are rectangles on the trigger layer. So these are triggers. And what a trigger is when a sprite collides with the trigger is set off. So again, Bob, which is my object on my sprite layer, his anchor point, which is near his feet, when that collides with the rectangle of the trigger, he gets transported over. So you can see that it's not when the first pixel touches. In fact, if I come from below, I can get a lot of Bob to overlap, but it's actually right when the feet touch. And if I go back here and turn my graphics on underneath, you can see that the rectangle is a little bit bigger than the graphic. So that's why as my feet approach, again, I'll turn the graphics off just to make it clear. So what's needed to make that function? And let's just start with the MapDoor that leads to the same map. It just jumps to the right. So if I click on this rectangle that's sitting on the triggers layer, I see two important factors. One, it has type MapDoor. That's its type. And the second one, it has a destination reference of whole. Okay. So to start with, having it type MapDoor is what makes sure it calls the right game mechanic. So that is saying that this trigger causes the game mechanic MapDoor to be triggered when a sprite enters it. And then this destination reference is a property used by that trigger. So I've just said a lot of words. So let's see what I'm talking about here. So if I go back into the engine server map.py, I will see that there is a MapDoor mechanic. And there's several things that happen here. But I'll go through all the code here, but in fact, I think there's only two functions. Yeah, there's only two functions here. There's the init and there's the trigger. So the init MapDoor, it sets a priority for it, but I'm not going to go into the details of that here today. But you can actually change the priority of when triggers and other functions get called. And you can see that more in the video that talks about server stepping. Okay, so the trigger is the important one here. So when the sprite anchor point enters the rectangle of the trigger, this function is called, and two things are passed. The trigger is the object of the trigger rectangle, and the sprite is the object of the sprite object from the sprite layer. So we have these two pieces of information. We know that the sprite is somehow inside the trigger, and we want to do something with that. So the first thing that we see is we want to make sure we have the correct data. So we're going to check the keys on that trigger object. And we're going to check for prop-destination reference. So this destination reference, you'll see, looks very similar. We've seen this just a moment ago. We saw it right here, destination reference hole. So this destination reference, when we look at it in LAN-Caster code, it'll actually show up like this as trigger prop destination reference. So it has the prop in front. That's been added by the LAN-Caster server just to make sure that we know that this is a property that came from tiled. It wasn't something that's been added by the engine. It's not a default thing. It's actually a custom property. So that's how we know. So if you add a property called destination reference in tiled, it's going to appear to you as prop destination reference, and you can access it just like this in this case of the trigger object. So this whole check keys thing, all it's doing is trying to do some error checking for us. So this code's not actually relevant. If you had perfect data and you knew that you never missed or forgot to add that destination reference, then you wouldn't need this code. So this is just checking to make sure that your tiled data has got the right data before we run the trigger. This way we don't have to check to make sure it's there. This will return if it's not correct. Okay, so once we get through this code, we know that we have the data we need to actually process the trigger. The other piece of data we don't know, though, is destination map name. So we can jump maps. So I'm going to assume that that's not the case. We'll do this again with the next trigger. So the destination is actually the same map. So what I'm going to do now is I'm going to find the destination map. Now this is fairly straightforward. I'm going to find the destination location. And I'm going to do that using find object. So on the map I'm going to, in this case it's the same map, okay? Because in this case it's this. So on the map I'm going to find the object. I want it to have the name of the destination reference, and I want it to be on the reference layer. Okay, so the object list I'm searching is the destination map reference layer. And again, this is one of those well-known layers. There's another video about server setup about well-known layers. So reference is one of my well-known layers. And I'm actually going to find an object that's a destination. So this is going to be a point object or a rectangle object. It doesn't matter. It's going to be an object on the layer that I'll have an anchor point. So let's just look at that. So we have our MapDoor rectangle. It's got a destination reference of hole. Now, if I go to my reference layer and I make it visible again, I see I've got a point object with name hole. And it's got a location. It's got an X and a Y location. So again, if I go back here, I'm doing find object, trigger prop, destination reference. That's going to be that string hole. So find an object with name hole that is on the reference layer. And that's going to return this test. Now, in Python terms, this is going to be a dictionary. So what that means is I can now, on that destination map, check the location. What would it be allowed to put the sprite that collided with my trigger on that destination map at the destination reference anchor X, anchor Y? So what I'm saying is the player collided with this rectangle here. Would it be valid to put the player sprite here? So that's what that check location is on. We talked about that in the previous game mechanic for the movement. If that's allowed, then I'm actually going to do set object map. I'm going to set the sprite to be on that map. Now, again, in this case, it's the same map as the one I'm on. I'm going to set its object location by anchor. And if the object was moving, I'm going to stop it. And then I'm going to return true. This is a detail here, but when you jump maps, normally you don't have to worry about this when you're writing a mechanic or doing a trigger, but the MapDoor, we want to stop all the other processing of triggers because the sprite's no longer on this map, so we shouldn't be processing other triggers from this map. So both this return true and what we saw earlier up in the init, which was setting the priority so that the map doors run first when we run triggers. Both of those are to make sure that if we're going to leave the map, that we don't process a whole bunch of triggers all at once. Okay, and that's it. We've done it. So the other map door, it works almost identically, except if we look at this map door, there is two properties. There's the destination map name, test04 map door 2, and destination reference, door to map door 1. So if I open that map, door to map door 2, and I just open that one up, I will see that there is a object on the reference layer called door to map door 1. So what that means is that this map door here, if I collide with it, it's going to cause the trigger to fire called MapDoor. It's going to try to transport that sprite, whether it's a player sprite or any other sprite that's moving that collided with it, to the destination map name here and the door to MapDoor 1. So the only difference in the code of this is determining here. So if we had this property destination map name, then what we actually do is we go and figure out which map that was. So we get our correct destination map, because it's not going to be the same as this map, as self. Okay. Now, also, if you try to send me to a destination map that doesn't exist, the whole server is going to exit. That's a complete failure of the server, so that's not good. So there are some checks and balances there. So that's how a map door works. So you can look here how to set it up. Now there's also another map door. So from the map test door 2 map, there's another door here, and this one takes us back to the previous map. So test 03 map door 1, and to a reference layer, it actually takes us back to this point. Now, a common thing that you might make a mistake on is you might have 2 map doors that are inside each other. So if this reference point was inside this map door, and if this reference point was inside this map door, the player would just bounce between the 2 maps continuously. Effectively just throwing the server into an infinite loop. So do make sure that your map doors aren't landing a player inside another map door, otherwise it will fall through both map doors. You can certainly set up your data like that. But that's effectively how you set up a map door. Oh, if you don't know how to add a custom trigger, the plus sign is just down here. So if we select our map door, you can say plus, and then add your properties. And these are just strings, the types. Okay. And that's a map door. So there's a few other ones we want to look at quickly. There's holdable, and we'll jump to that one next. So a holdable, and I'll just jump again, I'm just pressing F3. So a holdable is an object on the sprite layer that we can pick up, the player can pick up, and the player can drop. And these will only work for players. So just to look at that one, how you set up that, if we go back to maps, go look at holdable. So again, I'm going to turn off the text. So these are objects on the sprite layer now. So this one's, the one named chest, it has no type, but it's just an object in the sprite layer. The one called crossbow, again, and this is just a tile object, by the way, so you can just you can add a new one just by selecting, say, the book and selecting add tile object like this and paste it in, and then set its type to be holdable. That is all you'd have to do to make a new holdable. So if we look at the 2 that are there, the crossbow, it has type holdable. So the name isn't actually needed or relevant. It's just for our reference, but the type is. So that one's of type holdable. The book is of type holdable. And what this lets us do then is that when the player collides with the holdable on this layer, and I'll make my window a little bigger so you can read it, we get some action text pop up. And I can press the space bar to pick it up and space bar to put it down. Pick up the book, put down the book, and I can pick up the crossbow. I can just keep pressing the space bar to cycle between those. And things that you hold, if I press F2, I can go back to a previous map and I can drop it. So you can carry them between maps. So that is how the holdable works. So just to look quickly at the holdable mechanic. Again, you can look at this again. So we're back in the engine server map.py. So there's several things that happen here to make the holdable mechanic work. The first one is we need there to be a trigger that for the holdable mechanic. Now you saw in our map data that we set up, there's no trigger layer. These holdables only exist on the sprite layer, but we want to have a collision between the player and something. So when the player goes onto it, we want there to be that collision. So what we do to set that up is we actually look for all the holdables. So when the map initializes, it's going to call our init holdable for our mechanic, and we're going to search for everything of type holdable. But now by default, this is going to search for sprites, and we want it to return all. So it's going to return a list of objects of type holdable on the sprite layer. If you want to go read find object or go look at the code for it, it's in the map map.py, so engine map.py, and you can see how that works. It's a fairly simple function. So for each holdable sprite we find, we're actually going to add a trigger for it. And this is a pattern that you can use, and I'll just have a quick look at it for you here. So down in our mechanic, we have several steps to add a trigger for our holdable. And I'm not going to read all this, but you can go look through what it does. But effectively, it just copies the rectangle that surrounds that tile object as a rectangle onto the sprite layer. Onto the trigger layer. So now there's a trigger layer. We also do something called follow. And what that means is that if we move the holdable, which is on the sprite layer, the trigger object will actually move as well. So that's something the LAN-Caster game engine can do. But you can read through that particular thing. So in the initialization, we convert we copy the holdable sprite into a trigger so that it can trigger. And what this means then is that when the player enters that trigger, our function will be called trigger holdable, which is great because we just looked at how triggers work for the MapDoor. And in this case, what we're going to do is when the player enters something that's holdable, we say, is the player holding something? And if they're not holding something, then we're going to take some steps. If they are holding something, we're just going to ignore it. So, if I go up to the crossbow and I'm not holding, it says pick up crossbow. Now that I'm holding the crossbow, I have the ability to drop it. But if I go to the book, nothing. So I'm triggering the book trigger right now, but nothing's happening because of that. Because I'm saying if I'm already holding something, then to just skip this. This doesn't matter. If I'm not holding something, two possibilities could happen. The first one is that the player hasn't requested any action, and there's a whole thing I'll talk about later on about how actions work, but the player hasn't pressed the space bar effectively or asked for an action. And if they haven't, I can tell them they could. So if I'm not holding something and the player hasn't asked me to pick up anything, then I'm going to say to the player, available action, pick up, and holdable trigger was passed in. So that was the trigger object that was passed into my function. Now, if I go look at my trigger object in this case, it's got a name crossbow. And I said before, the name doesn't actually matter, but it's actually quite useful to set it, because if you have lots of holdables, when I go on top of crossbow, I want it to say pick up crossbow. So here I'm saying pick up, and then I'm adding the text, holdable trigger, holdable sprite, name. So you can look below again in that how the trigger was set up. I actually added a reference to the sprite so that I can get its name. But that will get us the sprite name. When you set up your own mechanics, this isn't super important, but you can see how that works. If I have, if there is an action that came from the player, in other words, the player set the spacebar, so the sprite has requested an action, I'm actually going to remove the action. I'm going to consume the action so that nothing else, when I press the spacebar, only one action should happen. So I'm going to do something. So I'm going to stop the action from happening for anything else. And then I'm going to pick up the holdable. And the pickup holdable is fairly straightforward. So I'm going to pass the holdable trigger and the sprite in. So to start with the holdable trigger, there's some setup here to remove things, but the real guts of this is that the sprite gets a new key called holding, and that sprite object is added. So to the sprite dictionary for holding, I actually add holdable. And I'm actually going to jump way ahead and show you what this looks like. So let me, in the game engine here, move far ahead, because there is actually, there it is. So there is actually a logging. So what you're seeing here logged is the dictionary that is the player object on the sprite layer. So as I move around, you're seeing that. You can see the move linear. You see the move right there, move linear. So if I go over to the crossbow, because there's a crossbow here I can pick up, I can actually press space. And now you see that there is a holding key inside the sprite object, and in that is another object from the sprite layer. And I can put it down by pressing spacebar again, and it drops it. So that's what that's doing. It's setting that sprite holding equals the object, and I can just walk around from map to map holding that. The other option is drop holdable as well. So to drop a holdable, effectively what has to happen, it's kind of the last thing that, sorry, let me find the correct place here. Pick up holdable, Stepmap End. Yeah. So when we talk about stepping, the server stepping, there's the trigger phase where it will call all the triggers for collision. But in the case of the holdable that we want to pick up, and I'll just stay on this map just so we can see it, we see that we have an available action drop crossbow. So I'm not inside a trigger that would do something else. Like the only available action I happen to have now is this drop. So at the end of a step, I have a function that'll get called Stepmap End. And what this says is that if a sprite is holding something, and I haven't requested anything, then I'm going to set the sprite text to be available action drop. So again, back here, I'm moving around. There's nothing else happening. There's no other available actions. So at the end of the step, this function will be called every step. And if there's nothing else happening, I'll just tell the user or tell the player that they can drop this thing. If they've requested that, so if that's available and they've pressed the space bar, which means they've requested an action, I'm going to consume that action. I'm going to call drop holdable. Drop holdables is very much like picking it up, actually, except it does the reverse. So it drops it onto the where the player is located. It makes sure that the thing that I picked up isn't moving, and it adds the trigger back in as we did when we first initialized it, because we could be on a different map. So we have to add that trigger, which we removed on picking it up. So those are all the things. You don't have to understand all the details of holdable. I'm just trying to show a demo of how you could use it in your game, and so you understand a bit of the basics of it, so that you can use it effectively. So let's pop back. So we talked about holdable. So there's a couple more things we can quickly cover here. And all the rest of this is covered heavily in other videos talking about designing maps and things like that. But this is just really about showing you the realm of possibility. So if I quickly go here, so this is a set of map layers. I highly encourage, especially for this one, that you actually open this one yourself and you see how this works. So if we go and open this map up, let me close the other ones down. And if I go to the layers one here, open map.json. So on layers, what you're going to see is a sprite layer that's been defined. And even though there's nothing on the sprite layer, I need it here in this case. I need it here because I have a whole bunch of layers that are on top of it. I also have some layers that are hidden. So this layer is marked as hidden. I also have some text, and this text says, hey, you shouldn't be able to see this text. And this is really a test to show you how you can layer and how you can create maps and where the player, or how it will appear with the player. So the player will go on top of things below the sprite layer and below things above the sprite layer. And layers that are not marked as visible will not appear. So very simple. This one's really, rather than me explaining, this one's much better for you to actually go look at and kind of explore yourself. So I'll leave that for you. There's nothing dynamic happening. It's just about how the rendering happens. If you want the details of that, there's a video on how the client and client map work you can look at, but it's really about render order for for the client map code. Okay. Shape. So almost everything I've shown you so far has been tile objects, but other objects are supported. So you've seen static text, you've seen text as well, but up here we have some tile objects. We have a rectangle, we have points, we have polylines, various different things. So this is just a render test. Now, there's not a lot of control on these other things, so I would recommend that you don't do a lot with things that most of your graphics are going to be done with tile objects or tile layers, because the other object types in tiled don't actually have a lot you can do with them. Now they are useful on other layers. The rectangles and circles especially are very useful on inbounds, out of bounds layers, trigger layers, reference layers. But as far as using them as graphics themselves, they're not that useful. I would definitely stick with tile graphics if you can. But all of these are here. You can explore this yourself. They're all up here. All of these would be on object layers, not tile layers, because tile layers only support tiles. But you can see up here all the tools to do that. And LAN-Caster supports several things there. Finally, I think, oh, right, and we also have map size. So the other interesting one here, this is a map that's a 4K map, so I'm just going to use the jump around. So map size you can set, and you can do large maps, small maps. This is just a test for both of those. You can open those maps yourself. If you want to open the map yourself, you can just look in here, test 09 small map. So that would be in, we are in LAN-Caster source engineTest maps, and that would be small map or big map. You can look at those ones. I'll just let you do that yourself. There's nothing exciting on those maps, just some graphic, just to prove that those maps can be used and do work. The next one here is font styles. This one will open the map for, just briefly. So let me just do file open. And let's look at text style. Because there's one thing to note here. You'll see this one here called custom font. And you'll see that it has a font type of ParkTech. Okay. But if I open it up, it doesn't say that. So I'm going to say cancel. So keep it as ParkTech. So in this case, if we look back over here, we see a very fancy font. So everything else you're seeing here are things you can do in tiled. There's different alignments, different colors, underline, bold, different font styles. But there's one other thing you can do in LAN-Caster as well, and that's add custom fonts. So if we go into the LAN-Caster source engineTest folder and we go to fonts, you can actually see I've added the ParkTech, and these are true type fonts. So you can add true type fonts here. The recommendation is you also add them to Windows. So if you add them to Windows, you can actually work within tiled as well. But this specifically is a test where I've gone in and edited the JSON file and set the font, which isn't installed on Windows, just to make sure that, yes, LAN-Caster can show a font that's not installed on Windows. And that's what that test is for. So again, if you find a free font online, again, add it to the credits file if you get it from someplace. And you can use them. I recommend you both put them in the font folder and install them on Windows. That way, if someone doesn't have it installed on Windows and they try to play your game, that they will still be able to see the font. All right. So that's custom fonts. And the last one here is just a test of tile animations. Now, this is just showing you how a tile animation can work. Again, I'll let you open this map yourself. Tile animations are covered in the video on tile maps, or tile sets, sorry, so you can look at that as to how to create these. But this is just a page full of different animated tiles. And I think I didn't necessarily outline on that video the fact that those tiles could live on anything. They can live on a tile layer, they can live on the sprite layer. They don't have to be sprites. I might have implied that in that video. And the next one here is a character animation. Now this does need to be something on the sprite layer more effectively, because otherwise you're not going to get the direction. So one of the things that Move Linear does, if we go back and look at it, it actually adds some data to the sprite. So if I go back to the engine. Oh, I actually have it here. So I'm in engine server map, and I go up and look again at move linear. One of the things it does is in the sprite, it adds a direction, which direction the sprite is facing. So if you use move linear, you get this direction. And then the client can actually use that along with the data from a character tile to give the correct standing still or moving. And this is something that's talked about again in the tile set video as to how to set up tile sets for character tiles. Okay. Again, you're welcome to open up all of those maps in Tiled and look at them directly. And again, the reference for that, the bottom right corner here tells you the name of the map that you're on. And that'll conclude this video. There is a bit of code for this character tile, but I'm not going to show it. It's just for testing purposes. The other part 2 of this video will look more at things that need to have code added to actually make them work. All right. Thanks, everybody.